The podcast opens with an exploration of the newly announced Genesis mission, a highly ambitious U.S. government initiative aimed at revolutionizing science through AI and accelerated computing. It draws a parallel to the Manhattan Project of 1939 and the Apollo Moonshot, emphasizing the sheer scale and ambition of this effort. The mission, led by the Department of Energy and helmed by Dario Gil, intends to unify federal scientific data with the country's most powerful supercomputers, shrinking research timelines from years to days. The initiative is focused on unlocking previously siloed federal data, providing it as critical reagents, and leveraging breakthroughs in biotech, fusion, and quantum computing. The collaborative effort aims to double American scientific productivity over the next decade, representing a fundamental shift in how science is conducted. Recognizing global competition, especially from China, the panelists highlight this as a strategic move to secure America's leadership in science and innovation. The Genesis mission is framed as a transformative, moonshot-level project with potential to reshape humanity's understanding of the Earth and universe. The conversation turns speculative and visionary, imagining what Thanksgiving might look like in 2035. The guests suggest dramatic advances, including personalized nutrition tailored to metabolic rates, ultra-cheap energy and food, and robots serving meals. They envision celebrations on Mars and digital celebrations via consciousness uploading, alongside the ethical complexities of uplifted animals seeking sanctuary. Devices inside humans will monitor metabolic processes real-time to optimize eating and drinking habits. Importantly, the guests agree that by that time, humanity should be living in a post-abundance era shaped by advances in AI, robotics, and energy, fundamentally changing daily life and societal structures. The discussion then focuses on Anthropic's launch of Claude Opus 4.5, a significant advancement in AI language and coding models. This release uses 76% fewer tokens to achieve the same results compared to older models and excels in programming benchmarks across multiple languages. It outperforms much of the engineering team during tests, marking a milestone in recursive self-improvement where AI systems surpass human capabilities in specialized tasks. The model's cost efficiency and high-quality code generation suggest a near future where software creation will be vastly accelerated and democratized. The panel highlights the evolution toward multi-agent orchestration in AI, fostering complex collaboration among AI entities. These advances hint at a coming economic revolution, where AI-generated software floods markets and labor dynamics shift dramatically. The guests debate how AI-driven tools like Claude Opus 4.5 will transform economies, particularly for individual entrepreneurs. They anticipate a surge in AI agents performing entrepreneurial functions, potentially generating billion-dollar enterprises autonomously within a few years. This dynamic could exacerbate wealth concentration, but simultaneously accelerate upward mobility, as the cost and barriers for creating scalable wealth shrink rapidly. The panelists emphasize a new economic paradigm, where AI agents act as neither pure capital nor labor, but a transformative hybrid, enabling the average person to participate economically by investing in fleets of AI entrepreneurs. This heralds a future where universal entrepreneurship and investment are powered by AI, creating new wealth pathways and disrupting traditional labor markets. OpenAI's introduction of ChatGPT's shopping research agent is discussed as a disruptive innovation poised to replace traditional product research channels. Unlike a standalone model, specialist vertical agents are emerging, each optimized for distinct domains like shopping, coding, or research. The panel explores how these AI-driven assistants will evolve into personalized layers that navigate the user's needs across all domains securely and privately, anticipating seamless integration into daily lives. They foresee these agents leveraging rich contextual clues such as eye tracking and natural conversation to predict and fulfill desires proactively. Amazon's Rufus shopping agent and growing investment in AI-driven commerce systems illustrate this trend, with significant revenue growth already emerging. The competition to provide the most engaging, trustworthy assistant experience is expected to intensify. The podcast highlights Google's release of their 7th-generation AI chip, Ironwood TPU, which offers 4 times the performance of its predecessor. Google is now renting TPUs as a cloud service rather than just selling hardware, competing directly with NVIDIA's GPU dominance. Their TPU architecture emphasizes massive interconnectivity and large context windows, enabling AI models like Gemini to handle up to 1 to 2 million input tokens, a critical advantage for truly advanced AI reasoning. This multi-supplier ecosystem of AI hardware, including AMD, Amazon's Trainium, and Google's TPUs, signals the commoditization of accelerated compute power, reducing dependency on any single supplier and fostering innovation and resilience. Amazon's commitment to invest up to $50 billion in AI infrastructure for U.S. government contracts underscores the scale of public sector demand for accelerated computing resources. This includes plans to add over 13 gigawatts of new data center capacity starting in 2026. Amazon's data centers, particularly a massive 2 gigawatt facility in Indiana, are central to AI model training and inference, including for companies like Anthropic. The chunk of farmland being converted into high-density computing centers is likened to a historic shift akin to wartime industrial mobilization. The podcast discusses Trainium 2 chips, Amazon's inference-optimized silicon, positioning Amazon competitively, though still somewhat behind NVIDIA and Google in specific workloads. The podcast shifts to space exploration economics, outlining dramatic reductions in launch costs, from billions per launch for the space shuttle era down to $2,500 per kilogram with Falcon 9 and potentially $100 per kilogram with SpaceX's Starship. The panel also discusses futuristic concepts like Jerry O'Neill's mass driver on the moon, which could theoretically reduce launch costs to mere cents per kilogram. Access to extraterrestrial resources from the asteroid belt and the moon represents near infinite abundance for metals, energy, and materials, potentially transforming the global economy and enabling vast space-based infrastructure, including O'Neill colonies with artificial gravity. The vision of disassembling celestial bodies for resources is presented unapologetically, prioritizing human expansion. Progress in brain-computer interface technology is reviewed, spotlighting paradromics achieving testing approvals for human trials, with data rates 20 times greater than Neuralink. The panel is optimistic toward Ray Kurzweil's prediction of high-bandwidth BCI by early 2030s, with the field evolving rapidly due to competitive innovation. They discuss different approaches, including invasive implants, non-invasive fMRI-based uploads, and futuristic nanotechnology-driven methods. The complexity of brain mechanisms is acknowledged, but phenomenological approaches may suffice for practical applications. BCI is flagged as not only a health and augmentative technology, but also a geostrategic necessity in an AGI-driven world. Imad Mostak's prediction of AGI arriving within roughly 1,000 days is examined alongside the question of what constitutes AGI. The panel agrees that generality has arguably been achieved since the rise of few-shot learning models circa 2020, with economic generality, machines replacing human labor in knowledge work, being imminent or already occurring. The rapid progress in AI capabilities suggests transformational shifts will unfold within a few years, necessitating agile societal response. Concerns over land scarcity in a future of AI-driven abundance are tackled with an Earth-plus perspective. Despite land being finite, the combination of expanded habitable areas, improved transportation technologies like passenger drones, and orbital or planetary expansion reduces concerns of scarcity. Virtual real estate in the metaverse and cloud-based human uploads further redefine what land ownership means. The discussion also considers the potential for increased land value depending on AI economy's utilization. Questions regarding how to prevent widespread poverty during the transition to AI abundance spark a thoughtful discussion on coordination challenges, government roles, and universal basic income or services. The need for universal AI assistance, Jarvis, for individuals to navigate access to food, healthcare, and social services is emphasized. Historical parallels, like the 1933 New Deal, are proposed as models for large-scale coordinated responses. The speakers stress that while the technology to end scarcity exists, the political and societal coordination to distribute benefits fairly remains the central challenge. The final discussion addresses concerns about mining celestial bodies like the moon and gas giants such as Jupiter. The guests argue that these bodies have significant material resources that humanity will inevitably tap to support expansion and economic growth. Jupiter currently protects the inner solar system from impacts, but in the future, technology could compensate for its resource extraction through protective measures. The idea to disassemble these bodies is embraced as part of a larger project of solar system transformation without posing a near-term threat to Earth's stability. The podcast closes with each guest sharing their gratitude for breakthroughs in 2025. They highlight progress in humanoid robotics, AI solving advanced mathematics, the growth of a radical and optimistic community around emerging technologies, the launching of AI social scientists to improve global coordination, and strides toward longevity escape velocity. They express optimism about the convergence of AI, energy, longevity, and human augmentation, bringing humanity closer to a Star Trek-like future.